So, welcome to part 2 of calculators. Specifically, ones that would be good choices for use in basic electronics, and then just an overview of different calculators, because not everybody's familiar with scientific calculators, and I think it can be a little intimidating, looking at these, because they have a lot more buttons than your standard basic calculator. How do you get to a lot of the special functions? So I want to show that a little bit. So a few things I want to do really quickly. I want to show you a calculator trap. You need to test any scientific calculator you have basically one time. Just punch in a simple formula and you'll know if you either need to or don't need to do something. Second, we'll probably cover speed. I just want to show a speed test to show you how vastly different the speed is that a calculator can crunch numbers. These two are, I'm just guessing here because I haven't actually tested it, but I'm guessing these two are probably going to be a lot faster than these two. These are going to be on the slow end, probably a minute to 2 minutes somewhere. Both of these probably 30 to 45 second range, and then also show using more, well, not so much more modern, because this is current manufactured calculators, but higher end calculators like a Casio. It could be an HP, it could be a Texas Instruments, doesn't really matter. But the ultra premium calculators, yeah, it's either you hit the button and the answer's there, or it might take 3 seconds or so. But it's a it's a nominal amount of time that's it doesn't really matter. But where these can take, some of these can take a considerable amount of time. Again, as I said in the first video, not really going to matter in electronics because you're not going to be doing a lot of probability and statistics where you're going to be crunching huge strings of numbers. So first thing is the calculator trap. What is the calculator trap? You can use any numbers in this formula that you want. It's just the order that you write it down, or you actually punch it into the calculator, is what you want to make sure you get right to test it. So we want to do something fairly simple. 6 divided by 2 times the sum of 1 plus 2. So we have 6, a division symbol, 2, a multiplication symbol, open parentheses, 1 plus 2, close parentheses. That should equal 9. Now, depending how you type this into certain calculators, you might get the answer of 1. 1 is not the answer we're looking for, because 1 is not the correct answer. The reason you can get the wrong answer is if you omit this multiplication symbol. Now, when you have a parentheses symbol here, anytime you put the number basically right up against the outside of that parentheses, that implies multiplication. So that's why a lot of people will not use a multiplication symbol. Because the 2 is right up against the outside of this parentheses, in mathematics that would imply multiplication. The problem is some calculators will do, and so normally the way this would work would be 1 plus 1, or 1 plus 2 equals 3. 6 divided by 2, because remember order of operation, and I'll get into that in a little bit more detail here in a second, but order of operation, you do anything in parentheses first, so that would be the 1 plus 2 equals 3. Then when you have multiplication and division in the same line, you do them in order from left to right. So we have 6 divided by 2 becomes before 2 times the sum of 1 plus 2. So you do the 6 divided by 2, that's 3. Now we're left with 3 times 3 equals 9. Pretty simple, right? The problem is some calculators do it like this. If you omit this multiplication symbol and you put the 2 right up against the outside of this parentheses, they'll actually do this. So it's 6 divided by 2, but notice there's 2 sets of parentheses here. So it'll do the 1 plus 2 first. 1 plus 2 equals 3. But then they've put this 2 into another set of parentheses. So that's the next function that would happen. So that would be 2 times 3 equals 6. Well, 6 divided by 6 is 1. And that's how the calculators come up with the wrong answer. Now, I don't need to test this one. I know it's going to do it. We'll just use this one. It could use either one. Doesn't really matter. But Now this Casio here, so if we, if I hit the right button to turn it on, if we punch that into this calculator, 6 divided by 2, now if I type it in with the multiplication symbol, we are specifically implying an order, because we're putting the multiplication symbol there. So 6 divided by 2 times, open parentheses, 1 plus 2, close parentheses, equals 9, the right answer. If I go and remove that multiplication symbol, now, don't pay so much attention down here to the answer. Watch what happens to this actual formula when I hit the enter button, or the equal sign. The formula is actually going to change, but that's a good thing because the calculator is letting us, it's basically letting us know why we got the wrong answer. It's showing you how it did the math. So I hit equals, ta-da! So you can see that extra set of parentheses showed up, and it's giving us an answer of 1. That's because it did the addition first, then it did the multiplication, then it did the division. So, like I say, it's nice that it does that. Now some calculators, here's a Texas Instruments, turn this one on, it doesn't care. Now I know for a fact if I put it in with the, well actually any calculator, if you put it in with the multiplication symbol, you'll always get the correct answer, 9. You got a 50-50 shot kinda with calculators if you'll get the correct answer though if you omit the multiplication symbol. So let's put that into this. So 6 divided by 2, open parentheses, 1 plus 2, close parentheses. Now notice the Texas Instruments actually, I got some glare there. Glare is always a problem. Notice that they don't use the division symbol. They put the slash here, so it's basically been fractionalized, 6 over 2 times the sum of 1 plus 2. But most importantly, when I hit the enter button, we get the answer, the correct answer of 9, even though we omitted the multiplication symbol. This calculator doesn't care. It does it correct either way. Now it's not just a Casio. It's not like all Casios are like this. We can bring this one down, the higher end of the calculators I recommended. If you specifically want one that can do programs, this one does it correct. So we turn this one on. We do 6 divided by 2, leave out the multiplication symbol, we'll just do the open parentheses, 1 plus 2, close parentheses, enter, and we get the correct answer of 9. So probably the biggest key is when you buy a calculator, either do this, or if you hopefully got an owner's manual for it, and Casio is pretty good with their owner's manuals. I've actually even marked the page here. There's an easy way to tell if a calculator is going to give you the correct answer or the incorrect answer. That's the order of operation. Now the standard order of operation, as most people would know it is, and actually would be parentheses and brackets, exponents and roots, multiplication, division, addition, subtraction, in that order. But there's actually a lot more to math than that, so it's nice that, and I need to find the page again because I took my finger out. Nuts. There it is. So here they give you a very detailed list of the exact order of operation. You can see there's more than 4 things. There's actually, they have 11 things to calculate, or 11 orders of operation. But from parenthetical function to functions preceded by values, power roots, standardized variant, percents, ENG notation, then you have fractions, prefix symbols, you know, the whole on down the line. But it's spelled out very detailed. So this calculator uses a slightly different variation of the order of operation than this calculator does. So like I say, the easy way to tell is either look in your owner's manual or just punch in a simple formula like this with, you know, without the multiplication symbol right there. If, like this calculator, you hit enter and you get the correct answer, you don't have anything to worry about. If you do it on a calculator like this and omit the multiplication symbol and you get the answer of 1, that's just something you need to be aware of. When you're doing a formula like this, you need to specifically remember to put put the multiplication symbol there. Just a little trap to prevent you from getting the wrong answer and you end up doing something, you know, designing a circuit. It doesn't even need to be electronics, it could be anything you're doing, but not knowing you're getting the wrong answer and not finding out until later on, and you know, which that could really screw you over in the long run then. So with that out of the way, I want to do, I don't want to drag this on too exceedingly long, so I'm going to try and speed through some of this stuff. Get all these cleared out. So the next thing we want to do, get all of these turned on, is a speed test. So for the speed test, we're going to do a fairly, yeah, it looks simple on paper. That is the formula right there. That's it. Okay? It's just a summation. If you don't know what that is, don't feel bad. I'm going to just really quickly describe what summation is. And this is something you could use in electronics. Maybe not this in this exact form, but you will use summation in some things in electronics. If you're doing like THD plus noise measurements, and you're doing it with an instrument that can't spit out the actual percentage, you know, your total harmonic distortion or total harmonic distortion plus noise, it can't give you a direct measurement. You might be using, let's say, a spectrum analyzer or a frequency selective voltmeter to measure the harmonics. So you would need to do that long form then. You do the math on it. You'd need to take measurement at all the different harmonics and then do the math. You'll use a summation formula when you're doing that. That's part, you know, the summation symbol is part of that. So the summation symbol is this Greek capital letter sigma. We have, this is the actual formula that's being, this is just basically instructions over here. This is the actual formula. X, and in this case I have x to the minus 2. Okay, summation means just that, sum, it's addition. So what it needs to know is, what is the value of x? The value of x is x equals 1 and every number from 1 to 500. So basically what the calculator is doing is it's doing 1 to the minus 2 plus 2 to the minus 2 plus 3 to the minus 2 all the way out to 5 plus 500 to the minus 2. So it's doing all of this, crunching that down, adding it all together to give you an answer. That's just a lot of math. Fast calculators can do it as fast as you can hit the button. Slow calculators can take what can get to the point of seeming almost like a painfully long time to do. So let's demonstrate that. Been pushing some buttons through the pad there, it looks like. So let's get this punched in, and this is going to be a good example of how inputting stuff into different makes and models of calculators can vary from manufacturer to manufacturer. So if we start out over here, I can get the glare off. Just slide the cameras over a little bit. Tilt my viewfinder so I can see if it looks okay. Okay, pretty glare free. So on this one, the summation logo or the summation formula is actually hidden under this applications. So I hit applications and you can see there's our sigma symbol. So in this calculator that's number 2, so we hit the number 2 and there's our formula, and this is natural display. So normally if you were typing something like this into a calculator, actually something like a because this one can do algebraic equations too, but if you put this one in algebraic mode, it's all in a single line. It doesn't have this what they call natural or textbook display. This is where I think some teachers might disagree with me, but like I say, learning math or relearning math, calculators like this, you don't really have to know that much about it. And if you're doing electronics especially, you're probably a fairly inquisitive person, or you wouldn't be tinkering with electronics in the first place. So being able to do the math when you need it is great. Calculator can give you the formula, you just punch in the numbers, it can do the math for you, and then, like I say, you're kind of probably an inquisitive person to start with because, well, you're taking the time to learn electronics, so at some later time you can actually go back and learn the math behind what's going on here. So, but it's not a hurdle, or it's not a roadblock. You know, you get to the point where, I can't do the math, and then you're stuck. like I say, as long as you can fill in the holes, the calculator does the hard work for you. It's not the ideal way to learn, but when you don't have an instructor, you know, you can't just raise your hand and say, hey, Mr. Joe Snuffy, could you come over here and help me? Well, there might not be a Joe Snuffy to come help you. You're stuck. So, yeah, these are kind of a stopgap, or they kind of fill in between that lack of not having somebody to help you, but still being able to get the math done. So let's enter that in here. So in this one, we need to enter x to the -2. The x is right here, a couple letters here, which are alpha functions. So I need to hit the alpha button. When you hit the shift button, that's anything that's in gold. That basically activates anything that's in gold printed on the calculator body here. If you hit the alpha button, that's blue. So anything that's printed in blue above these buttons has been activated. So I hit the alpha button, then I hit the close parentheses, and you can see there's a comma in gold and a X in blue. So that's how we get to those secondary functions, either the comma or the X. So I hit that, you can see the X appeared, and then we'll fill in the rest of it. 1 and 500. We'll slide over to this Casio. Now in this one, the summation is right here. So we don't have to go into a menu. It's right on, that's what I say. It's one thing I like about the Casios. They really cram a lot of stuff on the outside here. So I can just hit shift, hit, because that's what's in gold right there is the summation. Okay, there's our formula. Again, I just need to type that in. And again, I need to get the X in this calculator. It's actually in the same place. And actually, you know, that now that I see that, this Canon might actually be a Casio in disguise underneath the covers. It really might be. Let's see, -2, 1 to 500. Come over to the Texas Instruments, which has timed out, because yes, it does have a battery saving mode, even though it's got a solar cell. In this calculator, summation is hidden under the math, and that's what I say. Calculators like the Canon or this one, yeah, you're kind of stuck. If it's not written in, you can see there's not really a lot of advanced math functions written in on the case of the calculator. It's got a lot of them. It's just they're a little more complicated to find. They're buried in a menu. So in this calculator, it's under math. So I hit math, and then there's actually several columns wide. It's 4 columns wide of different things. But in the math, I then scroll down to there, and it says sum. So that's another thing. You would need to know you're doing a summation. It doesn't show you the sigma symbol. You'd need to know that's what this is. So I pick 5. There's our empty formula. 1, 500, x to the -2. And then we'll come over to this Casio. It's basically going to be the same as the first Casio there. So we'll just hit the, because it's actually in the same location right there. So shift, that gives us the formula. Now this one actually has a dedicated key for X. So I just hit that, gives us our X in the formula to the -2, 1 to 500. And okay, now what I want to do is make sure we got everything right here. Yes, 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 yes. So we'll try to get, I'll count down from 3 to 1 and try to push them all at the same time. So 3, 2, 1. Now these two should be done the calculation before these two. I'm figuring probably 30 to 45 seconds. These are probably both going to be over a minute. And this is a good demonstration of if you're doing something like statistics or probability in school. These calculators have a reasonably fast time. Okay, there's the answer here on the Casio FX991EX. That one's done. Waiting on this one now. Okay, this one just brought back the answer. And these are going to take a while. That's a impressive time for a standard scientific calculator, especially for scientific calculators under $20. That's an impressive time that they did that in. But these calculators, yeah, they're still, as you can see, processing and the screen's still blank because they're still thinking, they're still crunching the numbers. Well, if you're in a timed test, you're just sitting here now going, twiddling your thumbs. you're not doing anything. You're still waiting for the calculator to spit out an answer. So yeah, that's the one thing, the better calculators, you get what you pay for. Cost a little bit more, obviously does the math a lot faster. And they get a lot faster than these, actually, and I'm going to show that next. And man, I thought this Casio actually would have been done by now. It's actually a little bit slower than I thought. But like I said, in electronics, you're never going to be doing anything like, you know, harmonics from 1 to the 500th harmonic. That's just, yeah, that'd be unheard of. So, you know, this is a torture test that, yeah, might matter to people doing statistics or probability, but I did want to show that there can be a huge difference in processing speed. So, Jesus, calculators, any day now. Okay, finally, this Casio spit out the answer. And we're still waiting on the Canon. It'll come up one of these days. Wow, that's really starting to get to the point of almost ridiculous, isn't it? Okay, and there's the answer. Okay, so we've got our answers. But you can see the speed difference. Now I'll bring over the Casio, the FXCG. What the heck is this one? This is a 10. I've got the 10, the 20s, and the 50s. I just happened to grab, and I think this one's already been updated. No. I want to go menu. Yeah, this one's been upgraded to the current FXCG 50 software, actually. So, but we'll do the same formula with this one and this one, and you're going to see the huge difference there is. Even compared to how fast this one was, both of those are going to smoke it. One last thing I do want to show on these, as you can see the displays, the 3 left-hand calculators, the display quality of the text, or the numbers, is about the same. You can see the actual little dots there that make up the numbers. Same thing here. Like I say, all 3 of these calculators all have approximately the same resolution or definition. But you come over to this 991EX, look at the difference. I almost have to zoom in, and again on a big screen it'll probably look fine, but you can see how small the dots are that make up the letters compared to the dots that are used to make up over here. So that's why this one has much finer resolution, because it has the pixels, or the dots in this LCD display are just so much smaller. So it makes for a much nicer, cleaner display. So that's why I prefer this. Also, where most calculators have this type of display, it's kind of that purplish blue numbers. And no matter how you set the contrast, you always seem to have a little bit of that kind of purplish blue in the background. It just timed out, but kind of as a tint. This one, it's just, yeah, it's basically silver with black type. It's a little bit more crisp and clear to look at. That's why I said, and actually I looked up the price. I think I saw this one on at least on the CommuMart website. This one's like $12.97, and this one was, I think, $14.97. So yeah, actually I was wrong. It wasn't $16. This one's like $2 more than this one. Well worth $2 more buying, and there's absolutely nothing wrong with this calculator. Don't get me wrong. If you've got a 115 ES Plus, or you're more interested to get this one's perfectly fine. I just like this one because for just $2 more, I get that really nice display. It's really, really nice. So let me turn off some of these other calculators here. That one already timed out, and we don't really need to run the formula on this one. Again, you saw how fast it was. I am going to come back to this just to show some other options. So let's get that same formula punched into these two. Let's see, calculator summation, x minus 2 1 x 500, and we'll turn on the HP. Remember, this one has a touch screen, so this one's a little bit different. When you hit menus, a lot of the menus on this one, You can see there's a lot of stuff written on that button. Well, you don't actually get to it in the button, you actually hit the button and it opens up a window on the screen, and then you touch whatever you actually want to do. So, boink! So there's our summation. And let me fill that in. Let's see, X, 1, heck was I, X to the minus 2, 500. Okay, so I've got the same formula on both calculators. I know this one's going to, well, I'm not going to say it's going to smoke this one, but if you watch the answer, it's going to be almost instantaneous how fast it shows up. I'm trying to get it where there's no glare. It's going to be almost instantaneous. The instant I hit enter, the answer is going to be here. This one's going to take, 3 seconds or so. Honestly, that's a irrelevant amount of time. 3 seconds is, who cares? So we'll count down from 3 again. 3, 2, 1. And you can see, like I said, instantly there, and there's the answer on this one. So, like I say, you pay a lot more for the calculator, you get really nice fancy displays, you get much faster processing speeds. Like I say, I think this HP Prime runs at like 400 megahertz. I mean, that's just smoking the processors that are used, the chip on boards that are used in calculators like this. You get what you pay for. Let's just turn these off. I did want to show, now a lot of these calculators, and it's not just necessarily just this calculator, but they have a lot of additional features, these higher end scientific calculators. I say higher end, it's a, what I say, $14.97 calculator, but it has a lot of additional features. So in this one, if I hit menu, now this is actually one thing you'll see if I turn on both of these have a menu, but you saw how those higher end calculators back here have fancy app-based looking displays. This calculator is kind of like weaning you off of this type, which is all text. This one's starting to get that graphical look of icons, so kind of like more of the feel of a phone or a tablet, and which is basically how they operate. So it's kind of more like a app-based system here. They basically have the same things, it's just this one uses icons instead of just the text. This has the text down here too, so if you scroll across, you have your normal calculate in one, complex numbers, base n, which is important for us guys that are, if we ever have to do like decimal to binary for PLL programming, it's nice to have a calculator that'll do the conversions automatically. So this does decimal, hexadecimal, octal, and binary. But yeah, like I say, this one's got that app-based look. A lot of calculators are also going to find will do engineering. They won't just do scientific or engineering notation as in like 6 times 10 to the third or 6 times 10 to the fourth. They'll actually do engineering notation as in the prefixes. Or actually, it's not a prefix, it'd be almost, I guess, a suffix. But so if we go, let's see, shift setup. Now there's actually lots of things we can change in here. We can change the input and output mode. So like if we go into that, we can select how we're inputting information into the calculator. If I hit 1 here, and we can change the output. So is it the linear display, or line display, or is it a decimal display, or is it the natural textbook display? So we can control the different input and output types. If we type in one form, it can spit the answer out in a different form. That's selectable in here. Can change your angle units, the number format, engineering symbol. That's actually the one I wanted to show, and we'll get back to that, just run through some of the other things. You can set up your fraction results, so you can have either improper fractions or proper fractions, so either a whole number and a fraction or just a fraction. Complex, there's your statistics, your spreadsheet settings, equation and functions tables. Your decimal markers, you can change what the calculator actually uses on the display for the decimal mark, and for your digit separators. You know, you can have none, just a space, or you can have a comma. So, you know, like every, like if 100,000, you'd have 100, comma 000. That's, you know, the digit separator. Multi-line font, so you can actually change this display. You can actually shrink the size of it, so you can actually cram more stuff onto this display going through that. Contrast controls, and specifically this calculator has a really neat little feature I've never used because, well, I've got fancy calculators that do graphing, but my understanding is with this QR code you can input stuff into this calculator. If you were to have a problem or you wanted to send that to somebody, what you can do is generate a QR code on the screen of this calculator, scan it with, I guess, like your phone. You can download the Casio app from, I guess, like the, what is it, the Google Store or whatever the heck it is, what, the Android Store or Play Store, whatever. But you can download the app onto your phone or your tablet, scan the QR code on this calculator, and then you can actually, now remember, this is not a graphing calculator, but you scan that QR code and you can then view a graph on your phone, or you could like forward that to your computer and see it on a big computer screen. You can send it to somebody, so if you're having troubles with something, you could, you know, snap a picture of that QR code, send it to your friend, they can then open it up and look and see exactly what you're having trouble with. It's just kind of a neat little feature. Like I said, I've never played with it because I have no reason to. I've got calculators that can do it. You know, I don't need that, but that's an interesting little feature. Let's see, I wanted to get back to, okay, engineering symbols. So this is one that's kind of actually important for us guys and gals that play with electronics. If we go in and hit number 4, we can turn engineering symbols on and off. So we'll turn it on. Okay, and we can see there's an E up here now, so that lets us know we're in engineering symbol mode. So where we would use that is we can actually mix our input types. So if we were doing, let's say, capacitance, I could go into, no, options, there, engineering symbol. Okay, that's, so let's say we had 33 picofarads. Now we're not going to put farad into the calculator because that's kind of irrelevant, but we need to know what the unit is. So we're going to do something like maybe add 22 nanofarads to 33 picofarads. You know, we'll add a couple different values together that are using the engineering symbols. So let's say we had 33. I'd hit options, go to engineering symbols here, and we'll make it 33, let's say, nanofarads. So you can see there's our nano. We have our micro, nano, pico, and we have, you know, if you get into larger numbers, kilo, mega, giga, tera. So we'd pick 3. And you can see on the screen we have 33 nano. Now we can mix these together. So if we wanted to add that to, let's say, 22, I don't know, let's go into option, engineering symbol. We'll add that to, let's say, picofarads. So we'll hit, which is 4. So you can see now we have 33 nano plus 22 pico. But we can also mix in decimal numbers into this also. So if we wanted to add 0.000033, okay, sorry about that, my battery died on me. So I'm back. So this is where I was. I had 33 nano plus 22 pico plus 0.000033. Now I think I was right at the point where the battery died where I was going to hit the equals sign. So we hit equals, and you can see it's now spit out the answer, but it's spit it out with the engineering symbol. So it's 33.033022 micro. And if we were dealing with capacitors, that would be microfarad. So, like I say, just a handy thing this calculator can do. And we can actually change that display, you know, move the decimal point around and actually watch the engineering symbol change. So if I hit the engineering button here, you can see the decimal place shifted, and now it's 33,033.022 nano. And if I hit it again, it's going to switch over, and now it's reading in picofarads. And then if I shift and go, I can move the decimal place back over, you know, and even farther. So, you know, we can get, if we wanted to go down even farther, you know, go to the whole number. But like I say, just a handy little thing this calculator can do. So let me actually go back in, turn that off, that way I don't forget. A bad habit of doing that occasionally, setting up a calculator to do a special function and then forgetting to disable it, and next time I grab the calculator to do something else, I can't figure out why it's not giving me the right answer. Again, remember, the more complex the calculator gets, it's just that, the more complex it gets. So the next thing I want to do is break out the RPN calculators and just briefly describe what RPN is, how it works. Honestly, the best thing, if you really want to learn how to do RPN, download an HP Owner's Manual. Download something like the 15C Owner's Manual. HP not only made extremely nice calculators, durability, construction-wise, they also made really good owner's manuals. It's really hard to beat an HP Owner's Manual for describing what RPN is and how it works. So, yeah, I'm going to fumble it probably, because it's not that it's that complicated, but until you have that light bulb moment of, aha, that's how it works, it can be confusing. HP just did a really nice job. And honestly, we'll probably use the HP Prime, because that's one of the nice things about the HP Prime. It can do several different input methods. Unlike calculators like this can just do normal algebraic method or the textbook natural display, this HP Prime, if I go into the settings, I can actually change it from, come on, ah crap, I changed that, I think. I can change it, darn it, hit the right thing here, from textbook to algebraic to RPN, which is what I have it set up in right now. So, like I said, RPN really, really relies on you understanding mathematics. You need to understand math, and most importantly, you need to understand order of operation, because unlike a calculator like this, be it in algebraic mode or in the textbook display, you're still pretty much going to be entering your information just like it appears on a piece of paper or in a textbook. That's the big difference. You don't do that with RPN. RPN, you have to break down your formula, and that's why I say you really need to understand mathematics. You need to do it, the order of operation, that's how you need to input it into the calculator. This one doesn't really care. It does the order of operation itself. You put in a huge long string, long formula, and it will do each little individual piece in the order that's supposed to be done to spit out the answer. When you use an RPN calculator, you have to put that information into the calculator in the correct order, in the order of operation that it should be done in. You can't just type it in just as you see it on a piece of paper. So it forces you to think about the math. So, I guess that's probably why engineers and scientists like the RPN calculator. It forces them to actually think about it a little bit more. So, quite honestly, inputting the data into the RPN calculator may be faster, but in the long run, do you lose some of that speed of input with being forced to sit there and think about the math? And I think that's one thing a lot of HP RPN calculator fans don't think about, is there is increased time, because now you have to think about the formula first. What part do I need to do first to put into the calculator? You have to keep track of the stack and what's in your registers. I'm going to get into that in a second. So it's half glass full, half glass empty. Which is better? Like I say, if you've gotten used to RPN, you probably love it. That's great. I like RPN. I can use either of them. It's just something to be aware of. So, as I'd said before, order of operation is very important with an RPN calculator. If you don't put the information into the calculator in the correct order, it's never going to give you the correct answer. Now this is what I call the simplified version of order of operation. Parentheses and brackets are done first, exponents and roots, then multiplication, division, addition, and subtraction. And that's commonly known, a lot of times you'll learn in school, they call that PIMA. P for parentheses, E for exponents, M for multiplication, A for addition. And then what I have written down here is actually kind of like our formula up here. We had a division and a multiplication, which both fall into the same line of order of operation. So anytime you have that where two things fall into the same line of order of operation, you then do them in order from left to right. So, you know, in this case, you do the 6 divided by 2 because you do the division first, then you do the sum of that times whatever the sum is over here. So, RPN stands for reverse Polish notation. So, it's actually Polish notation is what someone in Poland invented. Like myself, the guy had a Polish last name. His is a lot more complicated to pronounce though than mine. So I guess you could say they were kind of smart. They didn't make it, they didn't use the guy's name, no offense to his name, but they didn't use his name knowing that, yeah, probably 90% of the planet would just end up mispronouncing it, you know, jibber jabber, yada yada notation. So they just made it Polish notation. HP does not use Polish notation, they use reverse Polish notation. So normal math, as you'd see it written in a textbook, as you write it on a piece of paper usually, like our 1 + 2 = 3. It's done from left to right. But the operator, what you actually want to do with these two numbers, the operation is actually placed in between the two digits that you want to do your math to. So it's 1, then you hit the plus sign, then 2. Polish notation would put the plus sign at the beginning of the formula. Reverse Polish notation puts the plus sign at the end of the formula. So that's why on the HP calculator you saw me input 1, hit the enter button, 2, and then I hit the addition symbol. So the easiest way actually to think about RPN is not in this form, from left to right. Think about it how you actually learn to do math in school. Now granted, anybody can add 1, I hope most people can add 1 + 2 in their head. But, you know, if you had large numbers, let's say a 10-digit number and an 8-digit number, and you needed to add those together, you don't put them beside each other like this because you have to carry on. You know, it's hard trying to carry ones over to the, you know, the previous number. Where when you have them stacked, again, there's that key, stack, that's what HP uses. When you stack the numbers, it allows you, let's say this was a 9 and this was a 2. Well, that would be 11. So you'd put a 1 and then you'd carry the 1 over to the next column. But if you think about math in this format, you're going to have an easier time understanding RPN because this is how an RPN calculator works. It works in this stack system. So it's 1, enter, 2, then you do the operator or the operation you want to do, the plus symbol. So and I'll probably demonstrate it. This calculator only has a single line display. This calculator has a 2-line display. For display purposes, I'm probably also going to show it on the HP Prime. The advantage of this calculator is all of these calculators are limited to a stack that has 4 registers. This one, there might be a limit, but I've never run into it. I've gotten up to like 18 or 19 registers before, and yeah, it's just crazy. But the nice thing is we can actually see it all on the screen, so I'll probably use this one at the end. But what HP has is the stack, okay? So I'll put the calculator here to block it out. So when you turn this calculator on, and there's my glare again. So when you turn this calculator on, you can see we have 0. And I have it set to 4 decimal places. I could give more or less. That's just the way I have it set up right now. But there's actually a stack, and it has 4 registers. The 4 registers are the X register, Y, Z, and T. What you're looking at right now on the screen is this X register. Up here in La La Land, where you can't see it, it's in the the calculator's memory, but just think of it as your calculator being taller than it actually is. There's actually a Y, a Z, and a T register up above what you see on the display here. On this calculator, it has 2. So you can actually see the X and the Y register on this calculator. And then again up here in kind of imaginary La La Land, where you can't see it, there is also still a Z register and a T register. So there's 2 of the registers you can see on this one, where this one you're limited, you can only see 1 register. Turn that off. So if you wanted to enter a string of numbers like 1, 2, 3, 4, okay, you'd punch. So down here, this bottom column, I have written key press. So the instant you push the number 1 on this keypad, okay, it shows up in the X register right here. Now if we hit the enter button, so that's what the E in the little box is representing, is enter. If I hit enter, now we have the 1 is still displayed in the X register, but anytime you hit the enter button, it bumps it up in the register. So the register actually, basically, think of it as moving up and down. So we actually have 2 1s. We have the 1 that we originally input into the calculator. We hit the enter button. It bumped it up in the stack to the Y register. It doesn't put a 0 here. I'm sure there's a reason for it, and I think somebody told me one time, I don't know why, but whatever the last number you had input into the calculator, that will remain in this X register, but the instant you hit another number, that'll overwrite that. I think they did that mainly if you needed to reuse that number, it was already there. Again, speed, it would prevent you from having to type in something again. But so if I hit the number 2 now, that overwrites that 2. So we now have a 2 in the X register, the 1 is up here in the Y register, and then we have the 0 and a 0 up in the other registers. If I hit the enter button again, we now have a 2 in the X register, the 2 that has been now bumped up to the Y register, a 1 in the Z register, and a 0 in the T. And it just continues on. So now if I hit 3, okay, that would be here. If I hit enter, that bumps it up in the stack. So now we have 3, 3, 2, 1. If I hit the number 4, we're good. We now have 4, 3, 2, and 1. We have 4 in the X register, 3 in the Y register, 2 in the Z, and 1 in the T registers. There's a problem though. There's only 4 stacks or 4 registers in this stack. If I hit the enter button now, okay, I bumped the stack up. We just lost the 1. It just went bye-bye. You could basically think of it falling out of the calculator. It just, it's lost. It's gone forever. So, if we actually roll down through the stack, and this has lots of extra little buttons. Like I said, I'm not going to get too complicated on how an RPN calculator works, but this little R button with the down arrow, that actually allows us to roll down through the register so we can see what's actually stored in these other registers. So we see we have a 4. We have the other 4, because remember, I'd hit enter, so there's a 4 in the X register, there's the 4 in the Y register. If I scroll down again, there's our 3 that's in the Z register, our 2 that's in the T register, and if I scroll down again, yeah, our 1 is gone. We're back to our starting point of X, okay? So that's something to keep in mind. There's only 4 registers. On the HP Prime, man, such a shiny screen. Well, actually, it's not that shiny if I'd turn it on. The brightness of the display actually overrides the overhead light. So I have this set up in RPN mode. So if I do the same thing, 1, enter. Now this one kind of shifts around. It may not be the best demonstration just because of the way the display kind of shifts around. But I punched in 1, enter. Excuse me. 2. You can see it's over here, and it doesn't say, you know, X, Y, Z, and T, so you kind of got to use your imagination, but at least it allows us to see the stuff going up into the stack. I hit enter. It's now moved it up into the stack. 3, enter, 4, enter. So you can see there's our X, Y, Z, and T registers. Now, when you hit an operation, so in this case, if we wanted to add all 4 of these numbers together, every time I hit the addition symbol, it's going to add whatever's in the X register and the Y register. And when it does that, the stack is then going to collapse, because you've now combined what's in, or you've done a math function with what's in those 2 functions, so they collapse and give you the result. So you don't lose what's up here. So if I hit plus, you can see we now had 4 plus 3 equals 7. If I hit the plus again, it's now going to add the 7 and the 2 together. That gives us 9. And if I hit it one more time, it adds the 9 and the 1, which gives us a 10. So that's how the stack rises and then the stack collapses as you do math functions. So if we do something practical, So like our formula up here. Now, to do this, the order of operation would tell us we do 1 plus 2 first, because that's in parentheses. So let's do that. I'll clear that out. If I do 1, enter, 2, so we have, man, this glare is just kicking my butt here. Let me change the camera angle. Shiny blasted screens. Okay, so we have 1, I did hit enter, I input the number 2. Now what do I want to do with those two numbers? I want to add them together, so I hit the addition symbol. That combined the 1 and the 2 to give us a 3. But now that's in the stack. So when I do this function over here, this math problem, this other little chunk, and that's what I say, with an RPN calculator you have to do it in little chunks. You're not inputting the formula as you see it on paper, you're doing it in little small pieces. So now we do this portion, the 6 divided by 2, so I hit 6, and you can see when I hit the enter button, that adds it, bumps it up in the stack. I'll hit 2. Now what do we want to do with those two numbers? We want to divide. So now we hit the division symbol. So it did 6 divided by 2, gave us the answer of 3. So then we want to do the multiplication of those two numbers. I'll hit the multiplication symbol, and it gives us the answer of 9. In a nutshell, that's how an RPN calculator works. Like I say, you either love it or you hate it. Most people hate it until they have that light bulb moment of, they have their aha moment, and how the stack works, really starts to register in their head. The advantage of the RPN calculators is you can do, it may seem counterintuitive, it may not make sense, but how do you do really complicated math with this? You got to remember, you're just breaking it up into little pieces. You don't lose the math, the answers that you gain from doing other previous math functions or smaller portions of a formula. They just get bumped up into the stack, and then you'll collapse down as you then combine those answers. It collapses down. You do more math functions, they get bumped up into the stack, and it falls. It just keeps rising and falling until you've done it honestly. And you can just go online, and actually it doesn't need to be an HP calculator. Most calculators, if it's a popular calculator, be it HP, Casio, or Texas Instruments, if you go online, you can download a calculator for free. I mean, you can get paid ones, but you can also get free ones. They're usually known as a calculator emulator. I personally like to have a calculator in my hand. I don't like using my cell phone or my tablet or my computer as a calculator. It's just not convenient. If I'm doing a math problem and the phone rings, I don't want to, if the calculator, that's all it does. It is a calculator. It does one thing really well, math. It doesn't talk to people, I can't take pictures with it. And I shouldn't have said that because, trust me, probably next year calculators will have cameras in the back of them. But that's actually another interesting thing you can do. These fancier calculators, when you're in like some of the trigonometry and your geometry modes, you can actually upload pictures onto your calculator and then plot points on that picture. So you can take a picture of a bridge or a picture of let's say you're in Egypt and you're looking at the Great Pyramids. You can take a picture, upload that picture onto your calculator, and then perform math functions on that pyramid. You could calculate the angles because you could put points on that picture and actually do the math off of a picture. Like I say, they have advantages. It just comes with complexity. This one's really nice, probably the best there is, honestly. And this is the next thing I want to do now is I want to demonstrate using a very simple 4-line program in this calculator to simplify, basically like a half-page worth of math. We're going to condense that down to basically 1 line. And that's all we'll have to type in the calculator to get our answer. So instead of having to do a half a page worth of math longhand or typing all of that into a normal calculator, using a program really simplifies sticking it in here. And then once it's in here, that program's in this calculator basically forever or until I delete it. So let's do that next. Like I say, this was just a quick, really quick demonstration of RPN. I highly recommend, if you're interested in RPN, if nothing else, just learning it a little bit more, go buy either an old manual or just download the manuals. You can download the manuals for pretty much any of the HP calculators. Just download the owner's manuals. There's no greater source of teaching on how RPN works than the HP books. Especially this 15C book gives you some really good examples. It's just real. They put as much effort, honestly, into their owner's manual as they did their calculator. It's one of the few companies that did that. Nothing wrong with Casio or Texas Instruments, but HP just blew their owner's manuals out of the park. I mean, they just went above and beyond. So they kind of wrote them in the, I guess you could almost say, military philosophy. Anybody that's been in the military, if you've ever seen some of the operations manuals for military equipment, they write them so no offense to the stupidest person on the planet, but military operations manuals are frequently written in a format that the stupidest person on the planet could understand. I mean, look at the land navigation. If you've been in the military, I'm sure you've seen the little land navigation comic book. They have a land navigation comic book that tells you how to use a compass. They had to make it a comic book so anybody could understand it. HP kind of did that with their owner's manuals. They take something that can seem rather complex, and they break it down into little chunks that are easily absorbed by your mind, and you can really get a good understanding of how they work. So I highly recommend that. Download a manual. Like I say, I know the HP 15C manual front to back. It's just a great manual. It's been around for decades. So, go take a look at that. And it gives some really, really good examples of how, with just a couple keystrokes, actually one of the first formulas you'll see it a demonstration of in the HP 15C manual is calculating the distance to two different stars, and you'll get both of the answers on the calculator at the same time. You'll be able to roll down through the stack, and you can actually, and it's just a couple button presses, honestly. It's just boop 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 boop, and you're done, and there's the answer. You've got two distances calculated from Earth to two different stars with both answers on the calculator at the same time. It's kind of hard to do with a lot of other calculators. Like I say, it seems complicated. It's not once you get used to the system, order of operation, and how the stack works. That's the most important thing, is this stack. Once you understand that this stack goes up and down, it moves. As you're doing math functions, as you're adding numbers in, the stack rises. As you perform math operations, the stack collapses as you're doing those math functions. So go check out the HP 15C, probably one of the best books. It's simple, because this was a more simple calculator. Where if you download the manual for this one, this is a very complicated manual, because this one does RPN and algebraic mode, adds all kinds of other functions. This is a very basic RPN calculator. Don't get me wrong, you can do very advanced mathematics on it, but layout-wise and the functions, it's still fairly basic, so it's a lot easier to read the manual for this calculator. So let me set up the Prime here, and we'll do an actual electronics formula demonstration, and I'll show you the advantage of having something like this. Like I say, it comes with complexity, but if you desire to have something like this, I'll show you some of the benefits of having that more high-end calculator. Okay, so this is a very, I guess you'd call it, popular schematic representation you'd see in textbooks. You'll find it online. God knows how many times I've seen basically this same circuit in books over the years. It's used, basically the goal of solving for this is, you want to know the equivalent resistance. If you were to stick an ohm meter probe here and here, what is the equivalent resistance of all of these resistors? So there's 9 resistors here. I have the resistance values written down over here. We have 3 parallel or series parallel combination circuits, grand total here. Okay. We have a series parallel combination here, because we have a series circuit, and that's in parallel with this resistor. So here's a series parallel. Here is a parallel circuit right here, and then this whole section here is another series parallel combination. So to calculate for parallel resistance, with only two values. Now there's two different formulas you use. You either have, there's one formula used for two resistors, and then there's another formula you use if you have 3 or more resistors in a parallel circuit. But in this case, we only have 2 resistors at most in parallel. So this is the formula we would use. Req, or the equivalent resistance, equals R1 times R2 over R1 plus R2. Fairly simple. So to calculate this out, if we were to do it longhand or on paper, this is basically running through this, everything you would have to do to solve for total resistance in this circuit. We'd add R5 and R6's value as 5 and 16 ohms equals 21. We then need to run our parallel resistance formula, because we now know this is equivalent to 21 ohms. R4 is 10 ohms, so it's 10 times 21 over 10 plus 21 equals 210 over 31 equals 6.77. Now, some of the answers here would actually run on the decimal places, would just on out here. Honestly, when you're doing resistance, you rarely would ever honestly need to get much below at least 1 decimal point. But I did take it out. I cut it off at the second decimal place. But 210 divided by 31, 6.77. So that is the resistance for this whole circuit right here. Then we need to add that equivalent resistance to this resistor that's in series with it, which is 5 ohms. So 5 plus 6.77. So this entire leg is equivalent to 11.77 ohms. Now we move down to this circuit. We have a 3 and a 9 ohm resistor, so 3 times 9 over 3 plus 9 equals 27 over 12 equals 2.25. Like I say, cut off to 2 decimal places. We add that 2.25 equivalent resistance to the value of R7, which is 2 ohms, so 2 plus 2.25 is 4.25. So we now have the resistance for this leg, 4.25. So we have 11.77 up here, 4.25 down here. We input those into the parallel resistance circuit or formula a third time to calculate for the entire resistance of this circuit right here. So 4.25 over 11.77 divided by 4.25 plus 11.77, and we end up with 3.12. That's the equivalent resistance of all of these series parallel combinations. Then we just need to add that to these two values. Then that's 5 ohms and 10 ohms plus the 3.122 for the entire equivalent resistance, which gives us a grand total of 18.12 ohms. It's not complicated math, not in the least. It's very simple, but it's just a lot of it to have to write down to calculate the total resistance. Now, if you were typing this into a calculator, you could ignore this second fraction I have here, but you would still have to type in all of this stuff at the beginning. You'd have to write down the answers either on a piece of paper or stick them into temporary memory on your calculator for those values to be used, in the next step of the equations. You can really simplify this, and all it takes. Now, this program is for this calculator, the HP Prime. Depending on what calculator you're using, the programming language can be completely different. It would be completely different on a Casio, because they use Casio basic programming. But on the HP Prime, with just this simple little program, okay, export RR, open parentheses, R1, R2, close parentheses. Begin, return, there's our actual formula from up top there, R1 times R2 divided by R1 plus R2, the sum of R1 plus R2. Close parentheses and then a semicolon, end semicolon. That's it. With just that little formula, we can take all of this, and all we need to punch into the calculator to come up with that answer is that. Just one little line. That's all that needs to be punched in. And we'll just do that really quick. Okay, so actually here is the program. Okay, there's parallel resistance. So if I... No. Escape. Okay, so actually there we're starting back where we did our speed test. So if I hit the shift program button, takes me in and shows me the programs. Like I say, I cleaned out all of the programs out of this, so this was basically the only one left in here. But I have parallel resistance, okay. If I tap on that, you can see there's the program. That's it. Just like I had down there on the paper. That's all there is to that program, okay. Now, actually, if we didn't want to use it in a formula like this, we just had two values. Let's say 3 ohms and 9 ohms. In parallel, what is the equivalent resistance? The nice thing about using this program, or making a program in this HP Prime, is I can use this little program, because it's actually going to be used 3 times down here. There's an RR there, and there. And that's actually, the calculator is going to run that program in these 3 locations when I punch it into the calculator. But it can actually be used in 2 different places. If I hit the run button here, you can see R1, R2. I can just use it just straight out, almost like a resistance app. And I didn't have to make this. It just kind of automatically creates this when I created the program in the calculator. So, you know, I could enter 3, enter, 9, enter. So we now have 3 and 9. Hit enter one more time, and the equivalent parallel resistance is 2.25 ohms. Just that simple. It's really nice. It actually, like I say, it's kind of like having the program in there 2 times. So let's say we want to run this program now. So we'll just type that in. Can I even get this all in camera? Maybe. Okay, so 5. Okay, and that's going to be the resistances. You know, the first 2 resistors are 5 and 10 ohms, so it's going to be 5 plus 10 plus, and we're going to be adding the equivalent resistance of the entire circuit. So I'm going to plus RR. That's my parallel resistance program. So in this calculator, what I do is I hit the little toolbox here, brings up my under the users section, because that's a users. In the glare, you can't see it. Under users, there's my stored programs, and I hit RR, and you can see it added a little RR to the screen with an opening and closing parentheses. Now we need to fill in that upper and lower series parallel combination circuits. So for the top one, we had a 5 ohm resistor in series. So 5 plus, I need to run the little program again, because remember, that was a series parallel circuit right here, okay? So that's 10 ohms. Actually, I need to put the little program in there again. I just lost it. RR, okay, then I need to do the 10 ohms. I put the comma, that's basically separating the top section of that parallel leg from the bottom section. Then I'm going to do 5 plus 16. That's those 2 resistors right there, the 5 plus 16. 5 plus 16. Going to scroll over outside of that parentheses. I'm going to put another comma. That's now going to separate this top section from the bottom section with that comma. I had the bottom single resistor here was 2 ohms, so I put 2 plus. I'm going to need to run for this parallel circuit, need to run my program one more time. So I go toolbox, parallel resistance, it adds the little RR there again, and then 3 and 9 are the value of those 2 resistors. So 3, 9. That's it. That's all I had to type in. 5 plus 10 plus RR, which is my little program. Excuse me. Open parentheses, 5 plus RR, open parentheses, 10, 5 plus 16, close parentheses, 2 plus RR, open parentheses, 3, 9, close parentheses. That's it. It's a lot less stuff to punch into a calculator than having to punch in all of this stuff here, and it's definitely a lot less than having to do it all by hand. And if I hit the enter button, you can see the answer, 18.12, yada yada yada. Like I say, anything after the second decimal place honestly is irrelevant when it comes to resistance in most electronics. So yeah, but there's the same answer, and we got it with nothing more than that one little line of formula, because we allowed the program to do, it's not the parallel resistance is exactly complicated, but it's saved us from having to enter the same thing in multiple times. Where, like here, we had to write down 10 2 times. We had to write down 21 2 times. You know, just by inputting it into the calculator only once automatically reduces the amount of stuff I've got to input, cuts it in half basically for every parallel circuit. I only have to actually type it into the calculator one time, not twice, for the top and the bottom of the fraction there. So, like I say, calculators like this are really handy. It's just the learning curve. And don't ask me about any of these calculators if you buy a calculator and you have problems. I'm not going to be able to answer your questions. I just don't have time for that. I just wanted to show some calculators I recommend, and calculators I don't. This is my favorite calculator. I think it's the most, pardon my French, badass calculator on the market right now, but it ain't for everybody. Unless you're familiar with advanced scientific graphing calculators, this may not be the best bet for you. You may buy this thing and have trouble doing 1 + 2 = 3, honestly. Honestly, you probably do be able to do that. And this has a lot of extra functions. Actually, all of these really advanced calculators do. They have apps for all kinds of stuff. Advanced graphing, geometry, 3D graphing, inference. There's different types of statistics you can do, spreadsheets, data streamer, because yes, you can hook up external sensors to this thing. Create plots and graphs using external thermometers and whatnot. Linear solvers, solving, explorer, triangle solver, finance, parametrics, polar, quadratic explorer, trig explorer, sequence, linear explorer. They're just, and you can add apps. You can make your own programs. Like I say, you can make your own apps if you're a good enough programmer to add stuff to these. You can go online and download all kinds of apps. Like I say, the only problem is the complexity of these things. It gets really, really hard, especially if you own, like me. Now, there's a few calculators I use all the time. I use the Casios all the time. I use a couple different HPs, and I'll use this one, and that's it. When I pick up a Texas Instruments a lot of time, calculators like these, which I do from time to time just to keep my memory kind of refreshed on how they work, but I have to relearn how to use these things because I don't use this style calculator on a daily basis. I may have to struggle for 30 seconds trying to find where in the hell is the summation in this calculator until I finally found it, under the math operation. But that's where, like I say, sticking with one brand. Now, granted, when you're a calculator nut like me, you've got all brands, but for most people, sticking with a brand, Casio, HP, Texas Instruments, whoever you choose, it's just suggestible to buy one brand, stay with that brand, and when you upgrade over time, like in the case of this one, if you bought a Casio, and you eventually did want to step up to a higher end, so you wanted to get into the Notepad, or into like the FX CG10, now this isn't their original version, and they came out with a CG20 and a CG50. This one has been upgraded to the CG50 operating system now, so for all intents and purposes, it's the same as the CG50, but like I say, it's just trying to go from this calculator to this one is a huge step. As you see, there's very few mathematical symbols on this screen. A lot of the stuff that you're going to want to do is buried in a form or buried in a menu here somewhere. So, in this case, I'd have to select one for the run matrix. I got to go in here, and when I want to find, like when I was doing the summation here, I'd have to know where I'm going to find that. So I'd have to hit options. I need to know that that's under the calc mode or calc button there, and then once I get into that, okay, I got to scroll over. There's the summation. But that's just one of those things. Like I say, it gets deep trying to find this stuff that on this calculator, all I had to do to get the summation logo on this calculator was, well, after I turn it on, hit shift, bam, there it is. On this calculator, starting basically from scratch, I'd have to hit the options button. I'd have to remember I have to hit the calculator button. I've got to scroll over to the right, and then I can get to it. And in other calculators, it can be even more complicated to find the net. Where this one, it's right on the face, shift, bam, it's on the screen. More complex, just that, more complex to use. But it does a lot more. You know, it's a balancing act. Get as complicated as you want. Just be forewarned. If you buy something like this, or like the Texas Instruments, like you get a CX CAS Inspire, just be forewarned. They're complicated to use. There's going to be a lot of reading involved to be able to use it efficiently. And don't come asking Mike for questions, because Mike ain't got time to give personal lessons to everybody on how to use their calculator. That's why I'm kind of picking these. They're kind of self-explanatory. That's why I like the basic standalone scientific calculator versus a graphing calculator, is their simplicity of use. So I hope that helps, you know, people making a decision a little bit, what kind of calculator to get, reasons to get these, like I just showed, over more complicated ones. You can't beat the price of the Casios, and honestly, it's not like the Texas Instruments cost that much more. They may be a few dollars more, and if the Texas Instruments are your thing, have at it. If you're interested in RPN calculators, you know, as far as input method, hey, try out an HP. You might like it. Some people hate it. You either love it or hate it. Honestly, that's all there is to it. I guess you could say I'm a lover. I like RPN. I just don't use it all the time. I've found, like I say, these new calculators, man, they're just... Not only that, the other advantage of this natural display is when I'm typing in long formulas onto the screen, in this one, I've got to break it up into little pieces. When I'm doing a very advanced formula with that stack and register system, I have to do one little section of a formula. Enter it. Do the next number. Enter it. Do the addition. Then do the next little portion. That gets bumped up in the stack. You can't see the entire formula basically on the screen. On a calculator like this, or the more advanced ones, you can see everything on the screen. It's all right there. And even on this one, if it falls off the edge, you can just, you know, scroll back through the formula to read. But you can see the entire formula on the display. Can't do that on an RPN calculator, because you're doing it little piece by little piece. And you need to do them in the proper order when you're doing it on an RPN calculator, or you're not going to end up with the right answer. So it is a lot more technical. RPN calculators are good for very technical people that know their math, know the order of operation. These kind of calculators are good for people that aren't that great at math, need a helping hand. There's your helping hand. The calculator itself is your help. So I hope that helps, and I hope you enjoyed and maybe got a little bit of useful information out of it.